we go. Thank you. So semantic versioning, unsurprisingly, is also versioned under semantic versioning, and it has reached version 2 already because that's how simple it is or easy it is. The general gist is you have major, minor, patch, aka the first one breaks stuff. That's the one you need to watch out for. The second one gives you features normally, and the third one fixes your bugs. So that's like the increments, how they happen and what to expect, and that's kind of like the general idea behind that. You can play the more advanced games, like who knows what is the lowest and the highest version in this list here. And this is something that nobody should know because that's kind of like almost an edge case. So if you're wondering, the lowest version is the one in the bottom left, the alpha, without anything. And the highest one is actually the one that is dash beta. Alpha beta is actually before, but again, nobody should know that. That's more like a trivia question that you could do about semantic versioning. So the one discussion point about semantic versioning is always like it's talking about the API, that if it breaks, you need to change the major version number. Only what is the API? If you have a product with an API like a REST API, probably that's the API. But maybe you also provide clients for your API, like I work for Elastic, we have clients for our APIs. Are the implementation details of our clients part of that major version? And especially for Java, we have not always seen it like that. The REST API was holy, but not the clients. Or what happens if you have like Docker images and the operating system support for those, like with RHEL or CentOS, is not around anymore? Is that a breaking change when you need to switch out images? Maybe, maybe not. Also, what is even breaking? I guess everybody knows XKCD. For most people, it's breaking, or it's like a minor fix, and for many other people, or some other people, it might be a breaking change. Also, what is about security fixes? What we have seen recently more and more is that there was some accidental feature that people were using in a weird or unexpected way that was not secure. Is that security fix suddenly a breaking change, even though you never intended that use? Yes or no? There's also the question like, is a UI change breaking, yes or no? Who thinks a UI change can be breaking? Okay, that's very few. Some people might disagree. Also, do you know what happens before 1.0? The zero ver instead of Semver, it's basically the Wild West. Like everything can break, which is funny because you probably use some software that is 0 point something. Another interesting or slightly weird effect of semantic versioning is that it's asymmetric, because adding a feature is a minor version, but if you want to remove that feature because it was not such a good idea after all, you suddenly need to create a new major version. So it's kind of like a little imbalance there. Finally, some examples. Kubernetes has this interesting approach of rolling forward. Like it does remove APIs and you can deprecate them, but it has like a specific set of like how long does an API need to be around and being able to roll forward to not break everybody's cluster all the time. So as long as you do all the Kubernetes upgrades, your data should be moved and you can update the deprecated APIs as well. If you use Terraform, it has reached 1.0 support or version by now, but it has given enterprise support for a 0 point something version, which had breaking changes for a long time, which some people found very interesting in semantic versioning. Also, Ansible is not using semantic versioning. And if anybody can explain like the differences between 2, 3, and 4 in Ansible in 5 minutes, you probably deserve your own talk for that, because it's pretty much mayhem. Finally, has anybody ever wondered why MySQL has these weird numbers? Like they have 5.1, then 5, 6, 7, and then 8? Like I've heard, like the rumor was that once Oracle bought them, is as long as you keep the same major version number, you don't need to do a full legal audit of your source code. That's why they kept releasing those 5.x releases. 6 was a Sun product that never shipped. 7 was a clustered product that never shipped. And then so the next version number they could use was 8. That's how they got up with those weird numbers. Finally, there's not just Semver, but also Calver, the calendar versioning, which makes a lot of sense. If you see Ubuntu, from the version number, you immediately know when that came out and if that is still supported or not. Otherwise, you might not know that. And then there was the odd even versioning number, like Linux 2.3 would roll into Linux 2.4 for the stable version. That's also not very common anymore. Most projects have actually given up on that. So semantic versioning is the thing. The only thing is most of us are do like kind of semantic versioning, and then everybody can have heated arguments. What does that actually mean? And it's probably the surest way to get into like a big fight to argue about what semantic versioning is or is not. Thanks a lot for joining.